Okay. Today we will be discussing about chapter 2 is matter around us pure. Here we have to know a little about the atoms and molecules.
Chapter
Chapter 2. Okay, this is page 14. Is matter around us pure? A pure substance consists of a single type of particles. A pure substance consists of a single type of particles. Okay, is matter around us pure? First come to this matter. Matter means anything which occupies space and has got mass is called matter. Anything which occupies space and has got mass is called matter. Occupies space means it has got volume. It occupies some space, that is volume, and it has got some mass. Mass means the particle contained in a substance. So when anything which occupies space and has got mass, this is called the matter. This one we have discussed in the chapter 1 also. So this is matter. Matter are of two types. One is pure substance and other one the mixture. The pure substance and the mixture. In case of pure substance, it consists only one type of particles and uniform. Okay, let's see. Substance. When we say substance, a pure single form of matter is called substance. A pure single form means only one type of particle is there. Pure substance, a single type of particle is present there. So it is a pure substance. Mixture. A mixture is one which contains two or more different kinds of particles, atoms and molecules, different kinds of atoms and different kinds of molecules. When it is present in a matter, that one we call it mixture. Just for example, in case of pure substance, an element like hydrogen. In hydrogen, it has got same type of atom. That is why hydrogen is a pure substance. At the same time, hydrogen is a matter because it occupies space and it has got a mass. In case of mixture, like say when we add a chalk powder with a soil, when we mix it, that becomes a mixture because these are made up of different types of particles. So a pure substance and a mixture. As a whole, matter is classified into two, pure substance and mixture. Pure substance means when same type of particles are there or one type of particles are there, it is called pure substance. And mixture, when different types of particles are present, that one we call it mixture. First, we'll be discussing about this mixture. Again, in mixture, there are two types. First step, as a whole matter, it has got two, pure substance and mixture. First, we'll study about the mixture. Later on, we'll study about the pure substance. In mixture, again, there are two types. One is homogeneous mixture and the other one heterogeneous mixture. Homogeneous mixture and heterogeneous mixture. These are the different types of mixture. So what is this homogeneous mixture and heterogeneous mixture? Just see in the difference directly. In case of homogeneous mixture, it has a uniform composition throughout. Uniform composition means the different types of particles are uniform of the same type, but not the same type of particles. Particles are of different type, that is why it is a mixture, but different types of particles are mixed up uniformly, where we cannot differentiate it easily. Example like, so when we add NaCl, common salt, in water, and when we get a solution, that one is a homogeneous mixture. So we call it a uniform composition, and there is no clear boundary between the particles. When we mix that NaCl in a water, there is no clear boundary between the particles of the water and particles of the NaCl. That is why it is called the homogeneous. In case of heterogeneous mixture, it does not have a uniform. As I said, like say chalk powder if you add with soil. That is a heterogeneous mixture. So when we get the mixture of a soil and chalk powder, we can differentiate it. We can identify it, the particles of the chalk and particles of the soil. We can clearly differentiate it. So it does not have a uniform composition throughout. This is the first point. Second is it has the same properties throughout the bulk. Bulk means, take the same example, NaCl in water. Throughout that volume, it has got the same properties. But in case of heterogeneous mixture, it does not have the same properties throughout the bulk. Like the soil and the chalk powder is white in color, and the soil it is gray in color. In that color, we can clearly differentiate it, and there is a clear boundary. The next point, there is no clear boundary between the component particles. Okay, this is inhomogeneous. And there is a clear boundary in between the particles in case of heterogeneous mixture. Example is given here. Solutions of NaCl and water, it is a homogeneous mixture. And air, even air or the atmosphere surrounding us, it is also a mixture and it is a homogeneous mixture. Because the constituent, like say maybe carbon dioxide, oxygen, nitrogen, all this combines to form the atmosphere. There is no clear boundary in the air. It combines with it combines uniformly, where there is no clear boundary between the particles, no clear boundary between the oxygen, nitrogen, or carbon dioxide. So it is a homogeneous mixture. An example of heterogeneous mixture, it is oil and water. When you try to mix oil and water, the two will remain separately. So there is a clear boundary. It is a heterogeneous mixture. Again, the soil and chalk powder, it is a heterogeneous mixture. So these are the difference between homogeneous mixture and heterogeneous mixture. Okay, these are the same, this is the point. Let's study this alloy. What is this alloy? Alloy, it is a homogeneous mixture of metal and metal or metal with non-metal. When we mix two metal, then we get the homogeneous mixture. And this is solid and solid. Both metal are solid and solid. In case of metal and non-metal, like say when we add iron with copper, then we get an alloy. So alloy, it is a homogeneous mixture of metal and metal or metal and non-metal. This is an example like brass. Brass is an alloy of 30% zinc and 70% copper. When we mix this zinc and copper in this ratio, in this percentage, 30% should be zinc and 70% should be copper, then we get a substance called brass. So brass is an alloy because this zinc is also a metal and copper is also a metal. So when we add this zinc and copper and forms a mixture, that is a homogeneous mixture, and that particular mixture, we call it the brass. Like stainless steel. This stainless steel, commonly we use it at our home, like it may be a glass or a bowl or all these things, that it may be a plate, stainless steel. So it is a homogeneous mixture of iron, chromium, and nickel. When these three are mixed, then we get the alloy, and that alloy we call it stainless steel. So these are some of the examples. We come to page 15. Page 15. Here below in that box, it is given alloys. Alloys are mixture of two or more metals or the metal and non-metal. You can underline. Alloys are mixture of two or more metals or metal and non-metal. Then in the last part, inside the box, it is given, for example, brass is a mixture of approximately 30% zinc and 70% copper. There is another example given here, steel. Steel is an alloy of carbon and iron. When we say steel, there is a difference between steel and stainless steel. Whatever we find, we use it at home as a glass or a plate, that is a stainless steel. But when we say steel, it is actually the iron rod or the grill. The iron rod used for constructions of our house building. Generally, in common, we call it iron rod only. But that iron rod, scientifically, we call it steel. And that steel is a homogeneous mixture, an alloy. And that is an alloy of carbon with iron. When we mix this iron and carbon, then that iron becomes hard. Otherwise, this iron, we can bend it easily. If it is pure iron, we can bend it easily. But when we mix some amount of carbon, which is non-metal, we get an alloy, and that alloy we call it steel, and this steel is hard and strong. We cannot bend it easily. So these are the examples of alloy. Now come to this solution. Solution. A solution is a homogeneous mixture. Again, come to this page 15. In the second column, you see what is a solution. A solution is a homogeneous mixture of two or more substances. You can underline. A solution is a homogeneous mixture of two or more substances. In that solution, one is of larger amount and the other one is of lesser amount. Take the same example like NaCl in water. When we mix NaCl with water, we get the homogeneous mixture called solution. The larger amount, it is the water, and the lesser amount, it is the salt. So when we mix salt in a water, we get a solution that is a homogeneous solution. So in a solution, always one part it is in larger amount, the other part it is in lesser amount. So what is this larger amount and smaller amount? Solvent. Now this in a solution, one is larger amount, the other one is lesser amount. The larger amount, we call it solvent. So the definition is the component of a solution that dissolves the other component in it is called solvent. That is a larger amount. So in a solution that is a homogeneous mixture, the larger amount, we call it the solvent. Same, take that example, NaCl in water. So that water becomes the solvent, and the lesser amount, what we call it? We call it the solute. So solute, the component of a solution which get dissolved in the other component. Other component means the solvent. The solute will dissolve in the solvent. Solute will get dissolved in the solvent. And the other one is the solvent will dissolve the solute. You just try to understand the sentence. Solvent will dissolve the solute, but solute will get dissolved itself in the solvent. So straight away you try to remember the larger amount in the solution is called the solvent, and the smaller amount in the solution is called the solute. So this is about the solvent and solute in a solution. And you remember solution is a homogeneous mixture. And this alloy, it is also a homogeneous mixture. Now just come back to this example in alloy. Brass is an alloy of the zinc and copper. Here the amount of copper is 70% and the amount of zinc is 30%. That means the copper becomes the solvent and zinc becomes the solid because the copper is in larger amount and zinc is in lesser amount. So the larger amount in a homogeneous solution or homogeneous mixture, and in solution, the larger amount, we call it solvent. The lesser amount, solute. Okay, here the example is given, salt in water. Salt is lesser amount, it is solute, whereas water is in larger amount, so it is a solvent. Type of mixture, okay. Again, there is different type of mixture. First, as a whole, that mixture is classified into homogeneous and heterogeneous. And the other classification is solution, suspension, and colloidal solution. Solution, suspension, and colloidal solution. Okay. First, it is a solution. Again, a solution is a homogeneous mixture of two or more substances. So solution is a homogeneous mixture of two or more substances. different type of solution. There is a liquid solution according to the state, solid, liquid, and gas. According to that state, there are different type of solution. That solution, it may be liquid and liquid, like say water and alcohol. When we mix water and alcohol, the mixture that we get, that is liquid solution. Since it is a solution, so it is a homogeneous. We, we cannot differentiate the particles of the water and particles of the alcohol. These two will mix up uniformly. That is why we call it homogeneous mixture. And this homogeneous mixture, it is a solution. This is a liquid, and the other one is solid liquid. One is solid, other one is liquid. Example is salt and water. Salt is a solid, water is a liquid. So it is a solid liquid solution. The next one is gas liquid. Carbon dioxide in water, that's soda. Soda is nothing but carbon dioxide in water. Even that cold drink we drink, the cold drink, that is there also carbon dioxide is there. Carbon dioxide in that solvent. So it is a gas liquid. Next is gas and gas solution, that is air. Air is a homogeneous mixture. At the same time, air is also a solution. It is a gas-gas solution. Gas-gas solution because the nitrogen, then oxygen, then carbon dioxide, all these gas are present in the air. So this is a gas-gas solution. All are gas. The other one is gas in solid, like carbon particles in atmosphere, or the example that we have taken, carbon with iron. Okay, next one is solid, zinc and copper. This is an alloy that we have taken the example. Okay, next, still in the type of solution. Now about the solute and solvent. Okay, you have understood. Solute, lesser amount; solvent, larger amount. So depending on the amount of solute present in a solution, it is classified as saturated solution and unsaturated solution. This is a type of solution. Again, this solution is a homogeneous mixture. First, you have to remember this one. Solution is a homogeneous mixture. So depending on the amount of solute present in that solution, it is classified into two again: saturated, unsaturated. In this unsaturated, dilute solution is there, concentrated solution is there. Of course, this dilute and concentrated, it is a comparative terms. When we say dilute, how much it is dilute, how much exact it is present, it does not define. But if the amount of solute present is in lesser amount, very less or somewhat less, then we call it dilute. But if the amount of solute present is more, then we call it concentrated solution. Take an example in a tea, a cup of tea. If the amount of sugar content is less, then we call it dilute. But if the amount of sugar present is more, then we call it concentrated. If it is very sweet due to the large amount of sugar, then we call it concentrated. But if the amount of sugar is very less, and if the sweetness is very less, then we call it is diluted. So these are actually comparative terms. Now come to this saturated solution. Saturated solution. Next, come to this saturated solution and unsaturated solution. Okay, saturated solution means when no more solute can be dissolved in a solution at a given temperature. It is called saturated solution at a given temperature, because when temperature increases, the solubility also increases. Just for example, when you want to add sugar in water and make a solution, take two same glass of same size, take equal amount of water. Again, you take 2 spoons of equal size and take same amount of sugar. So in that glass, you take one hot water and the other one cold water. Take same amount of sugar of same size spoon and you add it to that water. You will see that in that hot water, the sugar will get dissolved faster. That means temperature affects the solubility. When temperature is more, solubility becomes more. When temperature is low, solubility is less. So here, when no more solute can be dissolved in a solution at a given temperature, if temperature remains same. Suppose in a glass, take a water, that water temperature should remain same. Then you go on adding, suppose a sugar, it will get dissolved. Maybe slowly it will get dissolved. Go on adding, go on adding. At some point of time, no more sugar will get dissolved in that water. That point we call it saturated solution. So when no more solute can be dissolved in a solution at a given temperature is called saturated solution. That means if the solute becomes more than solvent, it will not get dissolved. It will remain as it is. So after saturation point, take the same example, sugar and water. If you go on adding that sugar in that glass of water, after saturation point, the sugar will remain in solid form. It will not get dissolved because it has come to the saturated point. So it has come to that saturated point. Okay. So this is saturated solution. And the other one, unsaturated solution. Unsaturated solution means if the amount of solute contained in a solution is less than saturated level. If that condition is less than saturated level, then we call it unsaturated. In case of unsaturated also, there is no particular point. So in case of dilute or concentrated, we call it unsaturated. Dilute means less solute, concentrated means more solute. But it has not reached the saturation point. So below that saturation point, we call it unsaturated. So if a solution is unsaturated, then more solute will get dissolved. After that, at a point when no more solute will get dissolved, that point we call it saturated. So this is about saturated and unsaturated. And again, the solute cannot be more than solvent because there is a saturation point. Beyond that saturation point, solute will not get dissolved. It will remain as it is. So this is about saturated and unsaturated solution. A solution may be more or less diluted or more or less concentrated. In case of dilution, we can say that it is less diluted or it is more diluted, or even in case of concentration, we can say it is less concentrated or more concentrated. Okay, just see the next slide. Concentrations of solution. These concentrations of solution you see the solubility. What is solubility now? The amount of solute present in a saturated solution is called solubility. Because solubility of different substances are different. It is not same. It is affected by the temperature also. Just for example, again, you take 2 glasses of water of the same size and same amount of water. And you see the solubility of sugar and NaCl. In one glass, you go on putting that sugar, and in the other glass, you go on putting that NaCl. The amount of that sugar soluble in that amount of water and the amount of NaCl salt in that water, it will be different because their solubility are different. So solubility means it is the amount of solute present in a saturated solution. At saturated point, how much solute it can be dissolved. That amount of solute, we call it solubility. The definition is this: the amount of solute present in a saturated solution is called solubility. The concentrations of a solution is the amount of solute present in a given amount of solvent. It is below saturation point. Once the saturation point reaches, no more solute will get dissolved. So when we say concentrations of a solution, it is actually the amount of solute present in that solvent. That is the concentration. It may be more or it may be less because it is a comparative word. We can say more concentrated or we can say less concentrated. So this is about the solubility. Now, how these concentrations of solution is expressed? We have to calculate. There is a numericals here. Generally, the concentrations of solution, how much concentrated or how much solute is present, how much solute is present in a given solution, we express in two ways. One is mass by mass percentage of a solution, and the second one mass by volume percentage of a solution. So these two you have to remember, mass by mass percentage of a solution and mass by volume percentage of a solution. So this is a formula, mass of solute by mass of solution. Since it is mass by mass, so we have to take the mass of the solute by mass of the solution, not the mass of the solvent. You remember, mass of the solution, and mass of the solution is equal to mass of solute plus mass of solvent. That will make mass of solution. I hope you are getting it. When it is expressed mass by mass percentage of a solution, it should be mass of solute divided by mass of solution into 100. So this is mass by mass percentage of a solution. So you'll get it in your book in page 16 and 17. In page 16 and 17. So the first one is mass by mass percentage. The next one, it is mass by volume percentage. Here you have to take the mass of the solute by volume of the solution because it is mass by volume. Again, remember here it is not volume of the solvent, it is volume of the solution. Volume of the solution equal to volume of solute plus volume of solvent. When solute and solvent combine, then we get about the solution. In the first case, it is about mass, mass by mass. In the second case, mass by volume. The numerator in both the case, it is mass, mass of solute. In the denominator, in case of mass by mass, in the denominator we take mass of the solution, and in case of mass by volume, we take volume of the solution.